Let's consider the polar curve r equals cosine of 3 theta and go ahead and find this tangent line when theta equals pi over 4. We'll go ahead and find that tangent line in Cartesian coordinates because I think that'll be a little easier. So I'll show you the image after we work through just the algebra of this problem. So remember, we're going to have to find dy dx by getting dy d theta and dx d theta. dy dx is going to give me my slope, and so I need that dy dx formula, which, recall, it's the derivative of r with respect to theta times the sine of theta plus r times the cosine of theta. That's corresponding all to the derivative of r sine theta, the derivative of y, over dr d theta times cosine theta minus r sine theta. So again, this is coming from the derivative of r cosine theta. Remember, r is a function of theta, and therefore we're using the product rule. So in my example, what will these formulas be? The derivative of cosine 3 theta should be negative 3 sine of 3 theta. And then the derivative, and so then we're going to multiply that by sine theta, and then we're going to add to that r, so cosine 3 theta times cosine theta. That's my numerator. And in the denominator, negative 3 sine of 3 theta cos theta minus cosine of 3 theta sine theta. Now we're going to input pi over 4 everywhere. So I'll note that the sine of pi over 4 is the same as the cosine of pi over 4. That's the square root of 2 over 2, or the square root of 1/2. The sine of 3 pi over 4, well, 3 pi over 4 lives in the second quadrant of the unit circle. It's that angle. And so its sine is positive, but its cosine is negative. So the sine of 3 pi over 4 will once again be root 2 over 2, while the cosine of 3 pi over 4 is negative root 2 over 2. So the slope we get is negative 3 times the sine of 3 pi over 4 times the sine of pi over 4 plus the cosine of 3 pi over 4 times the cosine of pi over 4, all divided by negative 3 root 2 over 2 times the cosine minus negative root 2 over 2 times root 2 over 2. Grouping like terms, we can see that m is negative 4 times root 2 over 2 squared divided by negative 2 times root 2 over 2 squared. And therefore, at the end of the day, I actually get that the slope is 2. So I have a line with slope 2. Now I want to get the point. So I'm going to get the Cartesian point. Well, x would be r, so cosine of 3 theta times cosine of theta. So in this case, that's negative root 2 over 2 times root 2 over 2, which is negative 1/2. And y would be cosine of 3 theta, the r value, times the sine of theta. So that's the same, negative root 2 over 2 times positive root 2 over 2. Once again, we get negative 1/2. So we have the point, negative 1/2, comma, negative 1/2 in Cartesian. This is x comma y. And we have the slope, 2. So as a Cartesian line, Cartesian equation, it would be y equals 2 times x minus a minus half, which is x plus a half, minus 1/2. And so then if I want to convert that so that I can get a polar equation, so we have this Cartesian equation. Let's go ahead and convert it to polar. I'm going to replace y with r sine of theta, and I'm going to replace x with r cosine theta. Then I'm going to go ahead and distribute. So we have r sine theta equals 2r cosine theta plus 1 minus 1/2 is just a net of plus 1/2. And so I'm going to bring all the terms that are multiples of r to the same side. So I'm subtracting that 2 r cosine theta term over, equals 1/2. And now I divide by that, and I get r equals 1 over 2 times sine theta minus 2 cosine theta. So let's go ahead and look. Here I've got a graph in Desmos of the curve cosine 3 theta. And I've drawn the line that we were looking at. That's this line here, 2 times x plus 1/2 minus 1/2. And you'll notice that this is the point -1/2, -1/2, where it touches the axis. In order to see what polar point that corresponded to, I created this point P1. And P1, here I'll change its color so that we can see it clearer. P1, I've set in T0 is pi over 4. So notice that what I've really got here is, since I'm writing a point in Cartesian coordinates to plot it in Desmos, this cos 3t0, that's corresponding to the r times cosine. And then there's r times sine. And so I have my point associated to pi equals 4, pi over 4. And we can see how it's located there. Notice the reason it's not out here in this quadrant is because of the fact that cosine 3 theta is a negative value when I plug pi over 4 in. And so I've reflected through the axis. So instead of having a point on this curve, on this ray here on this end, it's reflected through. Now let's go ahead and write the polar equation of that line that we just found. 1 over 2 times sine theta minus 2 cosine theta. And to make it real clear, we'll make it purple. And so here you go. Turn the line on, turn the line off, turn it on, turn it off. So hopefully that conversion also is helpful in seeing how to take that line and convert it to polar.